Hello my dear students, welcome back to NEET World. So today we will be discussing the continuation to the last discussion, that is equilibrium chapter, where we have started yesterday. Okay, so this is second class on equilibrium. Okay, so in the last class we have discussed what exactly types of reactions and when the equilibrium will exist, and then next what are the characteristics of equilibrium, okay, and what are the factors affecting an equilibrium, and how the value of equilibrium constant changes. These were the things we have discussed yesterday. Okay, so I will give you some important points from last class also here. Okay, and we know I think I also given you how can we relate Kc Kp also right now. Like Kc means equilibrium constant expressed in terms of molar concentration right now, whereas Kp means equilibrium constant expressed in terms of partial pressures. Okay, so this will be taken when the reactants or products are having gaseous particles, I mean gaseous reactants or gaseous products. Okay, so now here today we will be discussing the few more important topics. See, yesterday I have discussed about this graph, and if you haven't watched it, so just go and watch it, you will get more clarity on this topic. Okay, you can start from the very basic. Okay, right. Then next, law of mass action is discussed, and this some basic questions are also discussed. And then next I have solved some PYQs related to Kp Kc relation. So what is Kp Kc relation we have? So Kp equals to Kc into RT power delta Ng right now, where delta Ng is number of gaseous products minus number of gaseous reactants. This is what we discussed. So applying or by using this formula we can find answer for this kind of questions, right? Okay, so let us move forward with the new things here. See, yesterday I was discussing about characteristics of equilibrium constant. The first property I told you, the value of equilibrium constant does not changes if we change in concentration, pressure or volume, okay, or by adding some inert gas or anything like that, okay, or by adding catalyst, it will not be altered, the value cannot be changed here. But if we change the temperature, equilibrium constant value changes. It means the value of equilibrium constant depends only on temperature. This is the statement you can remember. Okay, so for example I am saying K1 is the equilibrium constant at a temperature T1, okay, and K2 is the equilibrium constant at a temperature T2. Okay, so now we have an equation which relates K1 K2 with the T1 T2 here. So we have log K2 by K1, log K2 by K1 is equals to delta H by 2.303 R 1 by T1 minus 1 by T2. Okay, so this is the equation relating equilibrium constants with the temperature. Okay, so now what is the main thing you should remember here? So look at here. For we have two types of reaction where we are studying like delta H. If it is negative, we are saying exothermic reaction right now. Okay, and similarly if delta H is positive, we are saying endothermic reaction right now. So based on this thing, now they will ask what is the relation between K1 and K2 if temperatures are altered here. Okay, what I told you, K1 is the equilibrium constant at T1 temperature, K2 is the equilibrium constant at T2 temperature. Okay, so now if for in the exothermic case, I am saying here if T2 is greater than T1. So what is exothermic means first? So exothermic reactions releases heat. It means that reaction is favored by lowering the temperature, lowering the heat of the system. Right now the temperature of system must be lowered. It means the final temperature must be lowered, therefore exothermic reaction move forward. Okay, so now here what is the condition I have mentioned? T2 is greater, it means temperature is raised. It means high, like we are increasing the temperature. Increase in temperature doesn't favor exothermic reaction, it favors only endothermic reaction. Okay, so it means if T2 is greater than T1, so low temperatures favor exothermic now. So it means at K1 K1, the value of K1 will be greater than the value of K2, because at T1 temperature, which is lower, we have higher equilibrium constant, because the exothermic reactions are favored by lowering in temperature. Okay, I hope this is clear. Okay, if I write, if T1 is greater than T2, then you can say K1, see here what I am saying, T1 is greater than T2. So here K2 will be greater than K1. Okay, hope this is clear what I am saying. Okay, next, when I say endothermic process, so endothermic process having delta H positive, it means that particular type of reactions are favored by increase in temperature. It means that forward reaction of endothermic process takes place by absorbing heat. So absorption of heat is nothing but rise in the temperature of the system, right? So rise in temperature means the forward reaction is favored by increase in temperature. It means if I say T2 is greater than T1, it means T2, at T2 we have K2 is the equilibrium. So by increasing temperature favors forward now, so it means K2 will be greater than K1. Like this you should understand. Hope this is clear what I am saying. Okay, yes, if these things are clear, just tell me in the comment box, clear sir, or just click on the like button. Okay, now move forward with few more things. Then next, what I have discussed in the last class is, I have discussed if an equilibrium reaction, if an equilibrium reaction is multiplied with n, if it is multiplied with a term n, then its equilibrium constant will be taken as Kc power n. It means just look at this example so that you will get more clarity than this definition and all, or this statement. So look at here, if A is in equilibrium with B, now for this particular reaction, equilibrium constant I am saying Kc, which is equals to something like 5. Okay, so now I am making it, I am multiplying this equation with number 2, that is nothing but here multiplied with n I am saying now. So here n is nothing but 2, so 2A will be gives rise to 2B. Therefore now we will be having a equilibrium constant as Kc dash. So what is the relation between Kc and Kc dash? This is the question they are asking. So now Kc dash is nothing but Kc to the power 2. Why it is to the power 2? Because for this particular reaction you will write equilibrium constant Kc is equals to concentration of product by concentration of reactant. Whatever the stoichiometric coefficients are there, take them to the power of that concentrations. Okay, right. So here Kc dash will be also written as Kc dash equals to concentration of B by concentration of A to the power whatever the stoichiometric coefficient we are seeing here, write it, okay, to the power 2. That's it. So what happened if a reaction, if an equilibrium reaction is, if an equilibrium reaction is multiplied with some number n, therefore its equilibrium constant will be taken as the power of that number whatever you have multiplied here. Okay, so here I am multiplying with 2, so therefore its new equilibrium constant Kc dash becomes equals to Kc to the power 2. That's it. Hope this is clear. Now Kc dash value becomes how much? Kc dash value will be equals to 5 to the power 2. That will be your 25 will be the answer. Hope this is clear. Now if an equilibrium reaction is divided by 2 or divided by n, therefore what you should take? To the power 1 by n you should take. Same whatever you have studied here, same thing we will be applying here. Okay, so look at here. I am taking similar reaction A plus B giving rise to some C. Okay, then what you will write? So for this Kc I am saying 36, equilibrium constant is 36. Now what I am doing here is I am dividing this equation with 2. So what I should write? 1 by 2 of A plus 1 by 2 of B giving rise to 1 by 2 of C. Then what is the equilibrium constant value Kc dash for this particular reaction? So simple, what you should do is take Kc dash is equals to Kc to the power, with what number you have multiplied? 1 by 2 now. So here take that number 1 by 2, that's it. Okay, so if I divide that equation with some n, so for example I am taking 1 by n of A plus 1 by n of B giving rise to 1 by n of C. I am writing like this. Now the equilibrium constant for this particular reaction Kc double dash is equals to Kc to the power whatever the number you have taken here as the stoichiometric coefficient, that take here as a power. Okay, that's it. Hope this is clear. So what will be the answer here? So what will be the answer here? Kc dash is equals to Kc to the power 1 by n. So 36 is nothing but 6 square I can write to the power 1 by 2. So it means it is 6. Kc dash is equals to 6 here. So this is how you need to solve the questions. There are many questions asked based on these particular concepts in the JEE and NEET exams. Okay. So if you are really preparing for your NEET and JEE exams, just go through this, go through the questions or go to the concepts of this particular characteristics of equilibrium constant. Okay. Now try to solve this question here. So try to solve this question. So what it is saying, see the reaction is given like this. Okay. Now further they are saying equilibrium constant is K. Now the same reaction is divided by 2. So now what happens? Its equilibrium constant, if it is divided by 2, Kc dash is equals to Kc to the power whatever the number they have used here. So they divided by 2 now. So you take that number here 1 by 2. Whatever the stoichiometric coefficient here is there, take that here. Okay. So here what will be the value here? Equilibrium constant Kc is given as K to the power 1 by 2. Okay. So we have option number 4 as our answer here. Okay. Right. Here before going to this question, look at here. So now what I am saying, if a equilibrium reaction is reversed, if a equilibrium reaction is reversed, then its equilibrium constant, constant is inversed. It means look at here, I will give you clarity on this thing. So for example, I have A plus B gives rise to some C. Okay. So this is C plus D, let us say. Okay. So this is how we have equilibrium constant. For this I am saying Kc. Okay. Right. Kc is the equilibrium constant. Now this reaction is reversed. It means C plus D is giving rise to A plus B. So now what happens to the equilibrium constant of this reaction? Okay. So here Kc dash I am saying. So how can you relate Kc dash to the Kc value? For example, Kc value I am giving it as something like some 2 number. Okay. So what happens to its Kc dash here? This is how they will ask you. Okay. So what happens here? So write Kc means what you will write equilibrium constant for this first reaction, you will be writing as Kc equals to concentration of product C into D concentration by A into B concentration here, right now. So whereas Kc dash will be written as concentration of products here, concentration of A into concentration of B by concentration of C by into concentration of D, like this we are writing now. So how can you relate Kc and Kc dash? So just look at them. So they are having some reciprocal relation. So what I can make? So Kc dash is equals to Kc dash is, see here numerator is nothing but denominator here, that is nothing but Kc dash equals to 1 by Kc. This is what I am saying here. Okay. Right. Hope this is also clear, right? So if a reaction is reversed, what happens to the equilibrium constant? It will be inversed. Okay. If this is 25, here it will become 1 by 25, like that. Okay. Right. Move forward. Yes. So yes, those who are watching, if this is clear, just tell me it's clear, sir, or I can repeat once again if you ask. Okay. Then next, if a reaction is taking place in multiple steps, if a reaction, it means if an equilibrium reaction taking place in multiple steps, then how you will be writing equilibrium constant for the final output. For example, A is giving rise to B and B giving rise to C, C is in equilibrium with D, like this they will be giving, and they are asking what is the equilibrium constant for A to D directly. Okay, by giving equilibrium constant for this single steps here. Okay, so K1 something like 2, some K2 something like 3, and K4, K3 giving something like again some value you can take some 3 here again, whatever you can take. Okay. So now what about K4 they will ask. So what will be your answer here? So what will be your answer? So just look at here, in each case how can write K1 means here, K1 is nothing but concentration of B by concentration of A. Okay. Similarly K2 is nothing but concentration of C by concentration of B. Okay. So K3 is nothing but concentration of C, concentration of D by concentration of C, D by concentration of C. Right now, so now look at them, try to multiply them, what you are going to get. So K1 into K2 into K3, you do this, just do this. So what you are going to get, concentration of B by concentration of A into concentration of C by concentration of B into concentration of D by concentration of C. Like this we have now. So just remove the things that can be able to cancel out here, right. So what we are remaining with, concentration of D by concentration of A. So that is nothing but K4 only now. So K4 means concentration of product here, D by concentration of A. So now what we can say, so by multiplying the equilibrium constant of these multiple steps in order to get this final step, just multiply the given equilibrium constants for each step. Therefore you will get final equilibrium constant K4, that is nothing but K1 into K2 into K3, like this, and so on if more steps are involved. Okay, hope this is clear what we are doing. So just multiply these numbers, so 3 to the 9 to the 18, that will be your answer for K4. Okay, hope this is clear. Now look at the question which I have shown you here. So now look at this, see here formation of ammonia we have, and formation of NO we have, saying K1, K2 and K3 here for water formation. Okay. So now finally they are asking, by considering these 3 reactions, we need to give the answer for this particular reaction. What they are saying, for this reaction what will be the final K? What will be the final K? So now look at here, what are the steps taken? We have discussed about if an equilibrium reaction is multiplied with 2 or multiplied with n or divided by n or taking place in multiple steps, so or a reaction is inverse or reverse, what happens, everything we have studied now. Apply all together into this question, you will get the proper answer. Okay. So what to do here is, first of all look at the question, look at this final equation, you have 2NO here, so 2NO is in this step. Okay. It means this reaction is taken as it is. Okay, maybe. Okay, and next here ammonia is at product side, but here ammonia is at reactant side. 2 ammonia, so 2 ammonia. It means the first reaction, it is reversed right now. Therefore its equilibrium constant in this final equation K, in this final K should be inversed, because first reaction is reversed, so equilibrium constant must be inversed. So I can write K1 in the denominator, right. Okay, and K2 equilibrium constant, second reaction is taken as it is, because product side you have 2NO, product side here also you have 2NO. It means I am taking K2 here as it is. And what about this K3 here? See how many water molecules are there here? Only 1 water molecule in K3, but in the final reaction you have 3 water molecules. It means this reaction must be multiplied with number 3. If it is multiplied with 3, then its equilibrium constant becomes K3 cube right now. So take here K2 into K3 cube, that's it. This will be your final answer. So look at the options, where do we have this kind of answer here? So K2 into K3 cube, K2 into K3 cube by K1. So first option will be perfect answer for this question. Hope this is also clear, right. Okay, next let us move forward with few more questions. Yeah, so I just want to ask you one question. So tell me for formation of ammonia, this is an equilibrium reaction given. So they are saying Kc is equals to, just assume that, so Kc is equals to 2 into 10 power minus 3. Okay. So now what I am making is, I just want to know the equilibrium constant for the reaction which I am writing here, NH3 divided by 1 by 2 plus 3 by 2 H2. So what is the equilibrium constant? Kc dash value here. Just tell me your answer in the comment box. So what I have did here, try to observe from here to here what is a change taking place here, and based on that you can answer your Kc dash for this reaction in the comment box. Okay, I'm expecting answer from you who are watching this video seriously. Okay, right. The next thing here is we need to learn about degree of dissociation. So degree of dissociation means what? So degree of dissociation means, for example, we are taking a reaction, A is giving rise to B, something like this. So we are initially we have at time t0 we have only reactant. Right now product concentration is 0. So if I say the number of moles taken initially here are some n, okay, after some time what happens, some number of moles from this n will be getting converted into this product side right now. So n minus some numbers, n minus some alpha here will be writing. So alpha here indicates degree of dissociation. It means number of moles taken initially, number of moles taken initially, and number of moles dissociated at a time t or at a time equilibrium. Oh, okay, this is what you are saying it as alpha value here. So read this question once. See, degree of dissociation is basically the amount of reactant dissociated at equilibrium if we start with 1 mole of reactant. Okay, so now look at this question for understanding purpose. Example here we have, suppose 5 moles of PCl5 is taken, and if 2 moles of PCl5 is dissociated, it means initially taken how many moles we have taken initially taken are 5 moles, and if 2 moles of PCl5 is dissociated, it means from out of 5 how many are dissociated? 2 are dissociated. So number of moles dissociated by total number of moles taken initially. The ratio of that is considered as degree of dissociation alpha. So here you will get alpha value as 0.4. Okay, so this is how you need to solve the question. Hope this is clear. Okay, right. Okay, so next we'll be solving few questions here. Okay, and I just wanted to ask you, based on yesterday's discussion and today's discussion, answer for these basic questions first. So look at this JEE question, which is very simple. Okay, read this question. I hope you are able to see this. Yeah, I hope you are able to see that question. Right. So tell me your answer for this question. So tell me your answer for this question. See, they have given for the given reaction, choose the correct expression for Kc. So how you are going to answer this? So Kc means concentration of products by concentration of reactants. That's it now. So very simple. So Kc means what you should write? Concentration of this ion. So Fe SCN plus 2 concentration by the ions here, reactants are Fe plus 3 and SCN minus. So for all of these the stoichiometric coefficients are 1 only, so you will get something like this. So where do we have this kind of option? So we have Kc for the following reaction. So we have somewhere here. So option number C or option number A will be your perfect answer based on our observation from the 4 options. Right? Right. Yes, Faizan, it's true in the comment box. Yeah, so next we'll move forward with one more question here. Yeah, so look at this. So this is also JEE question asking that if the figure shown below reactants A represented by square is in equilibrium with the product B represented by circles, the equilibrium constant here is. So what is the equilibrium constant they are saying? So we know reactants gives rise to products we are writing, which are in equilibrium. Reactants gives rise to products we are writing. Okay, so it means equilibrium constant Kc should be written as concentration of product by concentration of reactant right now. So what is the concentration of product here? That is represented by, concentration of products are represented by circles here. Just count number of circles here. So 1 2 3 4 5 6 7 8 9 10 11. So we have 11 here, circles are 11, products are 11, and reactants are, so 1 2 3 4 5 6. So you can say here reactants are 6. Therefore finally what you will get? So you are going to get, see, options are perfectly, we have 8 2 4 1. So like that, so it means 6 2s are 12. So the approximate answer here will be 2 right now. So option B will be more accurate answer out of the given 4 options. Hope this is also clear, right? Let us move forward with few more questions. Look at this question. Again, this question is based on our discussion only. Look at this question, try to answer this. Try to answer this, anyone in the chat box. See, okay, we already solved this question. Just now we have solved ammonia, 2NO is there, water is there. So we got answer as, okay. Yeah, so they have given, we have solved this model question. Based on that, you can answer here, very simple here. So what to take here? So final equation, equilibrium constant here, Kc will be equals to, what happened here? See, 2NO here you have, 2NO here you have. It means taken Kc is taken as it is. Here you can take Kc is equals to K2 multiplied with, what about this ammonia? This reaction is reversed. So you can take K1 in the denominator. We already solved this model question, but I haven't taken the values previously. That is, the question appeared in some other exam and this is in JEE exam. Okay, and next, what about the other thing? Water molecule, here it is 1 and here it is 3. So right now, so water molecules 3 means you just multiply this particular equation with 3. If you multiply with this 3, so your K3 should be cubed. Okay, so take here K3 cubed, that's it. That's it. Okay, now substitute the values over here to get proper answer out of this 4. So you will be having, so I can write 16 into 10 power 11, okay, Kc multiplied with K3 is nothing but 10 power minus 39 and by K1 is 4 into 10 power 5 we have. Okay, so these are the values we have. So just simplify these, you are going to get some particular value that will be your answer for the question. Okay, yes, yes. So one more please. Okay, yeah, so this is how you need to solve the question. Okay, next question we have. Yeah, so look at this question. The following 4 concentration were observed at 500 Kelvin for the formation of ammonia from N2 and H2. So at equilibrium, the concentration of nitrogen and concentration of hydrogen and concentration of ammonia were given. So you need to find its equilibrium constant Kc. Very simple. So what to do here? So ammonia formation you write. Okay, after this what they are saying, equilibrium constant value they are saying. So Kc means concentration of product ammonia to the power its coefficient, here 2 you take, and concentration of reactants N2 and concentration of H2 to the power its coefficient, here 3 right now. So next, what is the ammonia concentration at equilibrium? That is given as 1.5. So I can write, just I am writing it is 15 into 10 power minus 2, it means minus 3 I am writing to the power 2. Okay, and the denominator we have N2 concentration as 2 into 10 power minus 2 multiplied with H2 concentration as 3 into 10 power minus 2 to the power 3. Okay, so by simplifying this you are going to get your answer around 146. Okay, this will be the value of Kc here. Okay, right. Yeah, so Yes, those who are in the comment box, if you are new to this channel, please click on the subscribe button, and if you like the session, just click on the like button also. Faiz in the chat box, Faizan, Naitik, everyone. Yeah, so next, okay, now we'll go back to our discussion of equilibrium, right. So here we'll be asking you one question here, one more model here we need to discuss. For example, I have PCl5, which is a gaseous substance. It will decompose to give PCl3 plus Cl2. So now what I am doing is, I am giving you at initially at time t0, I am giving you 1 mole of PCl5. How many moles I am giving you? 1 mole of PCl5 I am giving you, okay, and I am asking you at equilibrium, at T equilibrium, what is the partial pressure of this gas? Partial pressure of this gas PCl3. What is the partial pressure of PCl3 at equilibrium? This is my question here. So what you are going to do? So 1 mole we have it initially, and these are 0, 0. So after some time, 1 minus alpha is the, like alpha is the degree of dissociation from this 1 mole. So 1 minus alpha you can write, and this will be alpha, and product formed here also alpha, as their coefficients are 1 and 1. Okay, and after this what to do? So now I am asking partial pressure of PCl5 now. So from Dalton's law of partial pressures, we have partial pressure of a gas is equals to mole fraction of that gas multiplied with total pressure, So P total. Okay, if I say total pressure of this mixture of gas, the gases is P, total pressure is P I am saying. So now what to do? What is the mole fraction formula? Number of moles of that gas by total number of moles. Okay, so now find total number of moles here, 1 minus alpha plus 1 alpha plus 1 alpha, right now. So just remove this, so you will going to get 1 plus alpha is the total number of moles, right. So total number of moles is 1 plus alpha. So now partial pressure of PCl3 I am asking right now. So partial pressure of PCl3 is nothing but number of moles of PCl3, that is alpha, by total number of moles, that is 1 plus alpha, okay, multiplied with total pressure of this mixture of gases at equilibrium, that is P. So this is how you should answer the partial pressures. Okay, so now even if I ask what is the partial pressure of Cl2, you will get the same answer, because the number of moles formed here are same. Okay, so the next, if I ask what is the partial pressure of PCl5 in this equilibrium, so your answer should be something like this. Partial pressure of PCl5 will be equals to number of moles of PCl5 at equilibrium, that is 1 minus alpha, by total number of moles, that is 1 plus alpha here, and P total, that is P here, that's it. So this is how you need to take. So what I told you, for P partial pressure of Cl2, that is alpha by 1 plus alpha into P. Okay, so now if someone asks you to calculate what is Kp for this reaction, Kp should be taken as partial pressures of products, partial pressure of PCl2, I mean this one, partial pressure of Cl2, and partial pressure of PCl3 by partial pressure of PCl5, like this we should take right now. So now what is the value of partial pressure of PCl2 here? We got from this thing, and for this we have here. So all you need to do is you need to substitute these things in this equation to get the Kp value. Okay, hope this is clear. And see, again they will mention some alpha value, like degree of dissociation alpha will be some 0.5 or some value they will mention, so that you will simplify there, okay, and substitute here, you will get the Kp value. Okay, hope everything that we have discussed till now are clear, and if you have any doubts, you can write in the chat box. I will be looking into it, and any doubts are there, I will clear in the chat box. Okay, so thank you for watching. Stay connected with this channel, and if you are new to this channel, what to do? Just click on the subscribe button, and you can share with your friends. Thank you.